Now I want to talk about introduction. What is ground anchor construction? Ground anchor construction is a widely used support method in civil engineering, especially for deep excavation projects, such as basement construction in urban areas. This method involves drilling steel bars, also known as anchors, deep into solid ground or rock and securing them in place with grout. Once installed, this anchor provides strong lateral support by holding the retaining wall in position and preventing the surrounding soil from collapsing into the excavation site. It is not only ensure the stability of the excavation itself, but also help protect nearby buildings and infrastructure from ground movement or damage. Ground anchor systems are particularly useful in locations where space is limited and deep digging is required, such as in city centers or tight construction zones. Their ability to provide strong and safe support makes them a preferred choice in modern construction for both safety and efficiency.
My name is Nurin Ishira binti Abdul Hadi, and I will explain the purpose and function of the ground anchor method in basement excavation. Firstly, soil retention. Ground anchors help hold the soil in place during deep excavation. This stops the soil from collapsing and keeps the site safe. Secondly, it allows deeper and safer excavation. This method lets us dig deeper compared to other methods because the anchor goes into strong layers like bedrock or dense clay, so it gives more support and safety. Next, protection of nearby buildings. This is very useful in city areas or places with limited space. The ground anchor helps protect nearby buildings and underground pipes from being damaged when digging the basement. And lastly, it increases wall stability. Since the anchors are placed outside of the working area, it gives more space for workers and machines. At the same time, it helps the wall stay strong, especially when there is a heavy load or pressure. In conclusion, the ground anchors are important for safe and stable basement excavation, especially in deep or tight areas. Thank you.
Next, let's at the method of construction. The method we are using is the ground anchor system. This system can be either temporary or permanent, and is commonly applied to stabilize retaining wall or the sites for excavation, especially in deep basement project. It works by countering lateral earth pressure. In the other words, the pressure of the surrounding soil or rock by anchoring the wall firmly into the ground. This helps ensure safety and stability throughout the construction process. Now, let's move on the method of construction beginning with step 1, site preparation. First, we conduct a site survey and soil investigation to assess ground condition and ensure the site is ready for construction. Next, we mark out the excavation area and well location currently based on design plan. Finally, if required, we will install temporary shorting or soldier pile to support the excavation and maintain site safety. This preparation phase is crucial to ensure a stable and well-managed start-to-be construction process. Next, let's look at the step 2 in the construction method, which is excavation in stage. The process starts by excavating to the first level, typically between 1.5 to 2.5 meter depth. After that, a retaining wall system will be installed. This may include sheet pile, diagram wall, or crescent pile, depending on the project requirement. Then, the excavation continues in multiple stages. This technique is commonly known as top-down excavation and is essential to maintain the stability of the surrounding ground during construction. Now, let's move on to step 3 in the method of construction, drilling for ground anchor. In this step, inclined holes are drilled through the retaining wall and into the stable soil or rock strata behind it. This is crucial for securing the wall and transferring the load to move stable ground. The drilling is done at an angle, usually between 50 degrees to 45 degrees from the horizontal. This angle approach ensures better anchorage and overall wall stability. This step is essential in supporting the structure, especially in areas with poor surface soil condition. Now, let's look at step 4, installing anchor tendons in our method of construction. In this step, we insert steel tendons or standards, which are usually high-tensile steel bar or cables into the previously drilled hole. It's important that this installation includes two zones, a bone zone, which is embedded in the rock or soil to provide anchorage, and a free length zone, which allows for stressing or tensioning of the tendon. This setup ensures the anchor can effectively transfer load from the structure into the ground. Now, let's move on to step 5, grounding the anchor. At this stage, we inject sealing ground into the drill hole to bond the anchor securely to the surrounding soil or rock. This process is critical because it ensures a solid connection between the anchor and the ground. Grounding not only provides stability, but also significantly improves the load transfer efficiency from the anchor to the soil or rock mass. This creates a more reliable support system for the excavation and ensures a long-term performance of the retaining structure. Now let's move on to step 6, anchor stressing, also known as tensioning. Once the ground has fully set, a hydraulic jet is used to apply tension to the anchor. Next, the anchor head is fixed to the wall using a bearing plate and nut to secure it in place. Finally, the design load is applied to counteract the earth's pressure and ensure the structure remains stable. This step is crucial for the overall integrity of the retaining system. Step 7 is monitoring and repeating. After initial anchor installation and excavation, we don't stop there. Instead, we continue the excavation process in carefully planned stage. As we go deeper, we repeat the anchor installation and stressing process to maintain wall stability. It's important to monitor wall movement and anchor performance on a regular basis. This continuous assessment helps us detect any shift or issue early on the make adjustment as needed to ensure safety and structural integrity throughout the excavation process. We are now reached the final step, final works. Once all excavation and structural support tasks are complete, attention turns to the fate of the anchor. Depending on the design and purpose of the structure, there are two options. For permanent basement system, the anchor are left in place permanently. This ensures ongoing structural support for the life of the building. On the other hand, for temporary systems such as those used during construction only, the anchor are distressed and then removed or cut. This step is essential for both safety and to avoid future complications. This final stage ensures the structure's long-term stability and compliance with engineering and regulatory standards.
Now I want to talk about advantage of using the ground anchor method in basement excavation. The first advantage is cost effectiveness. Compared to traditional method like constructing massive gravity retaining walls, ground anchors are a much more economical solutions. Second, ground anchor cause minimal disturbance to the surrounding environment. Unlike some methods that require extensive excavation and backfill, this technique involves less soil displacement. Another important advantage is the ability to support deep excavation. Ground anchor enable us to dig much deeper without the need for heavy supporting structure. And finally, adaptability. Ground anchor can be installed in a variety of ground conditions, including difficult or irregular soil profiles.
I'll be talking about the disadvantages of using the ground anchor method in basement excavation. While ground anchor are commonly used for supporting deep excavation, especially in urban areas, they do come with a few important drawbacks that we need to consider. Let's go through them one by one. The first disadvantage is the high initial cost. Installing ground anchors involve more than just drilling a hole and inserting a rod. You need specialized equipment, experienced workers, and proper testing to ensure each anchor is strong enough to support the load. In many cases, this method costs are compared to simpler excavation support systems like sheet piling or soldier pile with strap. So, if the budget is tight or the project is relatively small, the ground anchor method might not be the most economical choice.
Ground anchors require working space behind the excavation wall for installation. This space is needed to allow the drilling equipment to operate and to insert the anchors at an angle into the soil. This can be a major limitation when the site is located in a tight urban area or very close to another building because there is simply no room to install the anchors properly. In such cases, alternative methods that don't need bad access might be more practical.
The third disadvantage is the potential risk to nearby structures. If the anchors are not designed or installed correctly, they can cause ground movement such as shifting or settlement. This can result in damage to adjacent buildings, road or underground utilities like water pipe or cables. Also, if the drilling hits unexpected underground surface, it could lead to dangerous accident or costly repairs. This is why careful planning and site investigation are crucial when using this method. Finally, ground anchors are not suitable for every type of soil. They work best in dense soil, where the anchor can grip and generate enough resistance. But in soft or water-saturated soils, the anchor may not develop enough holding capacity, making the whole system unsafe or unstable. In some cases, additional ground improvement or different support methods are needed, which again add to the cost and complexity. In conclusion, the ground anchor method is a strong and effective way to support deep excavations, especially for basement construction. It helps keep the wall stable by transferring pressure to deeper, stronger soil layers. This method is very useful in tight spaces, like in cities, and allows work to be done safely. Even though it has some downside like being costly and needing space
with proper planning and installation, it can work really well. Overall, it's a smart and reliable choice for modern construction project. Thank you for your time and attention.
Thank you.